Satish Dhawan Space Centre or Sriharikota Range is a rocket launch centre operated by Indian Space Research Organisation. It is located in Sriharikota in Andhra Pradesh, 100 km north of Chennai. Sriharikota Launching Range was renamed in 2002 after ISRO's former chairman Satish Dhawan. SDSC's current director is Dr. M.Y.S. Prasad. He took over from M.C. Dathan on January 1, 2013 after the latter was appointed as director of LPSC. History: Sriharikota Island was chosen in 1969 for a satellite launching station. The centre became operational 1971 when an RH-125 sounding rocket was launched. The first attempted launch of an orbital satellite, RONI-1A aboard a satellite launch vehicle, took place August 10, 1979, but due to a failure in thrust vectoring of the rocket's second stage, the satellite's orbit decayed August 19, 1979. SHAR was named as Satish Dhawan Space Centre SHAR, on September 5, 2002, in memory of Satish Dhawan, former chairman of the ISRO. The SHAR facility now consists of 2 launch pads, with the second built in 2005. The second launch pad was used for launches beginning in 2005 and is a universal launch pad, accommodating all of the launch vehicles used by ISRO. The 2 launch pads will allow multiple launches in a single year, which was not possible earlier. India's lunar orbiter Chandrayaan-1 launched from the centre at 6:22 a.m. IST on October 22, 2008. SHAR will be the main base for the Indian human spaceflight program. A new third launch pad will be built specifically to meet the target of launching a manned space mission by 2017. Location: Satish Dhawan Space Centre is located on Sriharikota, a spindle-shaped island on the east coast of Andhra Pradesh. Features like a good launch azimuth corridor for various missions, nearness to the equator, and large uninhabited area for a safety zone make it an ideal spaceport. SHAR covers a total area of about 145 km2 with a coastal length of 27 km. Prior to its acquisition for ISRO by the Indian government, it was a firewood plantation of eucalyptus and casuarina trees. This island is affected by both southwesterly and northeasterly monsoons, but heavy rains come only in October and November. Thus many clear days are available for outdoor static tests and launchings. SHAR is linked to Sriharikota by a road across Pulicat Lake. Sriharikota has connectivity with other parts of India by Indian Railways and is on a National Highway 5 that connects it to Chennai South and Kolkata. Launch history: originally known as the Sriharikota Range and later named after Satish Dhawan, it is India's primary orbital launch site to this day. The first flight test of RONI-125, a small-sounding rocket which took place on October 9, 1971 was the first ever spaceflight from SHAR. Since then technical, logistic and administrative infrastructure have been enhanced. Together with the northerly Balasore rocket launching station, the facilities are operated under the ISRO Range Complex headquartered at SHAR. Satellite launch vehicle: the range became operational when 3 RONI-125 sounding rockets were launched on 9 and 10 October 1971. Previously, India used Thumba Equatorial Rocket Launching Station, on the west coast of India, to launch sounding rockets. The first test launch of the complete SLV-3 rocket occurred in August 1979 but it was only partially successful following a malfunction in the second stage guidance system. SHAR facilities worked satisfactorily during the SLV-3 preparation and launch. On July 18, 1980 the SLV-3 successfully launched India's third satellite. Out of the 4 SLV launches from SHAR, 2 were successful. Augmented Satellite Launch Vehicle: the ASLV orbital launcher was integrated vertically, beginning with motor and sub-assembly preparations in the Vehicle Integration Building and completed on the pad within the 40 am tall mobile service structure. The first ASLV launch from SHAR took place in 1987 and resulted in a failure. Eventually, out the 4 ASLV launches from 1987 a 94, only 1 was successful. Polar Satellite Launch Vehicle: The PSLV launch complex was commissioned during 1990. It has a 3,000-ton, 76.5 am high mobile service tower which provides the SP-3 payload cleanroom. The solid propellant motors for the PSLV are processed by SHAR, which also carries out launch operations. The first launch of the PSLV took place on September 20, 1993. Facilities: the center has 2 operational orbital launch pads. SHAR is ISRO satellite launching base and additionally provides launch facilities for the full range of RONI-sounding rockets. The vehicle assembly, static test and evaluation complex and the solid propellant space booster plant are located at SHAR for casting and testing solid motors. The site also has a telemetry tracking and control center, liquid propellant storage and servicing facilities, the management service group and Sriharikota common facilities. The PSLV launch complex was commissioned in 1990. It has a 3,000-ton, 76.5 am high mobile service tower which provides the SP-3 payload cleanroom. The solid propellant space booster plant processes large-sized propellant grains for the satellite launch vehicles. The static test and evaluation complex tests and qualifies different types of solid motor for launch vehicles. The control center at SHAR houses computers and data processing, closed-circuit television, real-time tracking systems and meteorological observation equipment. It is linked to 8 radars located at Sriharikota and the 5 stations of ISRO's telemetry, tracking and command network. The propellant production plant produces composite solid propellant for rocket motors of ISRO using ammonium perchlorate, fine aluminium powder and hydroxyl-terminated polybutadiene. The solid motors processed here include those for the first stage booster motor of the Polar Satellite Launch Vehicle, a 5-segmented motor of 2.8 am diameter and 22 am length, weighing 160 tons with a thrust level of 450 tons. Rocket motors and their subsystems have to be rigorously tested and evaluated on ground before they are declared flight-worthy. The facilities at SDSC-SHAR are used for testing solid rocket motors, both at ambient conditions and simulated high-altitude conditions. Besides these, there are facilities for conducting vibration, shock, constant acceleration and thermal humidity tests. SDSC-SHAR has infrastructure for launching satellites into low Earth orbit, polar orbit and geostationary transfer orbit. The launch complexes provide support for vehicle assembly, fueling, checkout and launch operations. The center also has facilities for launching sounding rockets for atmospheric studies. The mobile service tower, launch pad, preparation facilities for different launch stages and spacecraft, storage, transfer and servicing facilities for liquid propellants, etc., are the principal parts of the PSLV-GSLV launch complex. For supporting the GSLV Mk3 program, additional facilities are being set up at SDSC. A new plant is set up to process heavier class boosters with 200 tons of solid propellant. The static test complex is being augmented for qualifying the S-200 booster. Other new facilities include a solid stage assembly building, satellite preparation and filling facility and hardware storage buildings. The existing liquid propellant and cryogenic propellant storage and filling systems, propellant servicing facilities will also be augmented. The range instrumentation system will be enhanced further. Launch pads, SLV launch pad. This launch pad was used by the Satellite Launch Vehicle and Augmented Satellite Launch Vehicle is located at the southern tip of the current launch site. It has been decommissioned. Initially it was built for launching SLV-3s but was later also used as an ASLV launch complex. First launch pad. The modern first launch pad was built in the early 1990s for the Polar Satellite Launch Vehicle. It has also been used by the Geosynchronous Satellite Launch Vehicle. The 20th launch from the pad, a PSLV-XL with IRNSS-1A, occurred on July 1, 2013. Second launch pad. The SLP at SHAR is a state-of-the-art launch complex. SLP is configured as a universal launch pad capable of accommodating all the launch vehicles of ISRO, including the advanced launch vehicles to be built in the next decade and beyond. It became operational in 2005. Third launch pad. The third launch pad is specifically being built for manned missions at a cost of $6 billion. References. External links: Satish Dhawan Space Centre official website, Chandrayaan-1, Sriharikota on Encyclopedia Astronautica, about SHAR Centre, Federation of American Scientists, Satish Dhawan Space Centre, SHAR Centre layout.